All right, everyone, welcome to the Space Prize Speaker Series, Episode 9. It is June 29th, 2022, and here we are with Vanessa Clark of Atomos Space. She is the co-founder and CEO. We're really excited to learn a little bit more about her career trajectory today, and to, of course, learn more about Orbital Transfer Vehicles, which is the subject of the bulk of their work. I am Mark Wagner. I am the president of the Space Prize Foundation. I'm really thrilled to be a part of this program and to be a part of this series of guest speakers. And going to go ahead and introduce our host, Leslie Anderson, in just a few minutes. And she will then, in turn, introduce Vanessa in a little more depth. First, though, I want to say a few words about Space Prize. We have just wrapped up a couple of weeks ago our inaugural prize in New York City. We worked with 5 public high schools in the 5 boroughs of the city. And in January, we put on an essay contest. In February, the finalists competed in a video contest. The participants being, by the way, young women in the New York City public high school system, ages 14 to 18. Our focus is to inspire and empower young women to pursue STEAM education, that's science, technology, engineering, and math with the arts, and also to explore careers in the growing space industry. This particular series, of course, is open to students, educators, and enthusiasts everywhere. But in New York City, when our finalists finished their video competition in February, our judging was in March. And by the end of March, we had 25 finalists participating in a simulated mission to Mars at the Challenger Center right there in Manhattan, which was a great experience for everybody involved. That same week, through a partnership with Female Quotient, the 25 finalists all had their pictures up on massive billboards in Times Square, brought grandparents in from out of town to see it, and everything was a big deal for the local kids. Right around the corner in April, we sent 4 of the winners to the Space Camp Leadership Program, Space Camp Lift in Huntsville, Alabama. So a great travel opportunity for them as well, and the first of the prizes that the winners received. And we also had our own Yuri's Night celebration for them in April. Then in May, 5 of the winners got to go on a parabolic zero-G flight and experience weightlessness. As you can see in this picture, through another partnership with Gaze in Space, Star Trek's Denise Crosby joined them. She played Tasha Yar in The Next Generation. She was on the bridge there in the first season. And our very own executive director, Kim Macharia, you see there on the left, got to fly with them as well. So it was a very, very special day and a really impactful experience for all of them. Oh, wrong way. We have a number of other programs going on. If you head to spaceprize.org, you can see there what else we're up to. One of the things we're doing right now is a similar challenge in Paris, France. Their first round essays are due this Friday. There'll be a video challenge to follow, and we'll be announcing, we'll be honoring the finalists at IAC in September and announcing the winner of a zero-G flight there in France as well. At which time we hope to be announcing our Israel challenge in the fall. So we're very excited about those regional challenges right now. We've also asked ourselves from the beginning, what do we do for the girls that don't win? The speaker series is part of the answer to that. But another part of the answer is the space education curriculum that we're working on, with the first chapters due out later this week. Dr. Leslie Anderson, our host, is also working on that program with me. And the rest of the online Flexbook due out by the end of the summer. So stay tuned for that. When it comes to this speaker series, though, for those of you that have been following along, you know already, we're featuring astronauts, engineers, and scientists, but also folks from all across the space industry, entrepreneurs, designers of various kinds. We've got the spacecraft interior designers, zero-G fashion designers, space lawyers, space historians, academics of all kinds, astronomers, all from around the space industry with various career trajectories to getting involved with this, humanity's future. So that's what brings us here today. We're excited to have Vanessa with us and to hear more of her story. And for those of you that are with us, please do, as Leslie said before we started the recording, please do participate in the chat. If you haven't already, go ahead and share where you're from. Looking forward to catching all of those and welcoming all of you. And at any time, go ahead and use the raise hand feature to interject or ask your own questions. Or really, in this small group, feel free to just unmute and interrupt. Certainly, if we invite you to, feel free to unmute or share your screen if appropriate. We've had some really fun moments with the participants sharing information too. And of course, if you need any help, you can send me a direct message, drop something in the chat, or use the help feature, which will send me a message. Now, between some of our questions or after some of the answers, we may leave a little bit of wait time to find out if our guests or any of the participants have more to say, and to give you guys an opportunity to jump in with additional follow-up questions before we move on. So just know if there's a little bit of wait time in there, that is by design. Well, any questions about any of this from any of you before we get started? No, well, with that, I will go ahead and introduce our host, Dr. Leslie Anderson. She is a Albert Einstein Distinguished Educator Fellow in Washington, D.C. right now, assigned to the Library of Congress, which sounds just idyllic. She has been a teacher at the high-tech high school in San Diego. She has researched sea turtles, giant great white sharks, and Arctic ice cores. So she's been a part of adventurous scientific expeditions all over the world. And if I understood it right, you were exploring neutrinos in the ice cores. So maybe we ought to dig into that story sometime. Leslie is working with us now on the curriculum at Space Prize, and of course, hosting this show. So one way or another, we're thrilled to have her with us. And Leslie, go ahead and take it away. I know you'll do a great job introducing Vanessa, and I can't wait to hear how the interview goes.
Awesome. Thank you so much, Mark, for that introduction. I'm excited to announce and share with you all Vanessa Clark, who is a co-founder and chief executive officer at Atomos Space. She is an experienced aerospace engineer with expertise ranging from advanced concepts to hardware development and production, with an emphasis on in-space propulsion and space nuclear power systems. After obtaining advanced degrees in physics and mathematics, in aerospace engineering and management in Australia, Vanessa worked as a research engineer in Germany from 2011 to 2015 for Airbus Defence and Space, formerly Astrium, and DLR, the German Aerospace Center, in the fields of spacecraft systems engineering, spacecraft and rocket propulsion, and space mission design, including for the nuclear electric spacecraft program MegaHit. Relocating to the US in 2015 after receiving a green card, Vanessa took on a role as principal propulsion engineer and manager at Lockheed Martin in Colorado. Engaged in projects ranging from military satellites to human spaceflight, she led the design, testing, and production of spacecraft propulsion systems for NASA and other government customers. In this role, she was able to recover late and over budget programs, modify requirements and processes to reduce the burden of government inspections program-wide, and was selected to participate in Lockheed Martin's Next Gen Leadership Program. Vanessa co-founded Atomos with a goal to remove the barriers to accessing space that she experienced in her roles, both as a launch vehicle designer and spacecraft developer and operator. In particular, she's passionate about promoting sustainable space utilization and realizing next generation space power and propulsion technologies that will enable humans to access space beyond Earth orbit. Vanessa, welcome. Thank you so much for being here. And the first thing that we're going to ask is, tell us about your work. What do you do for Atomos Space?
Oh, thank you so much for the kind invitation and the nice introduction. Definitely feels like I've done a lot when you read it out like that. So I've been leading Atomos Space now for 3 years. So we're a startup based in Denver, Colorado. We're currently 22 people, and we're building something that I see is really important for the future of humanity and space flight. So not just NASA human space flight, but space exploration and commercial space operations. So Atomos's goal as a company is to make any orbit accessible. So the problem that we're trying to overcome is how we get satellites and cargo to space today. So launch vehicles are really suboptimal for going beyond a low Earth orbit. We can talk more about why that is and how we're overcoming it. But in essence, we're building what we call orbital transfer vehicles. So these are tugboats for space that are able to relocate assets in orbit. And so as a company to date, we've raised venture capital, we've won millions in government contracts, we've done a lot of hard development work in our facilities here in Colorado, and we're starting to assemble our first 2 orbital transfer vehicles that we're launching in about a 1.5 years time. So it's been a fun journey to date, but definitely a long way to go still.
Can you tell us a little bit more about the importance of orbital transfer vehicles?
Yeah, so during my career, I had really interesting experiences. I got to see both sides of the curtain. So designing rockets and then designing satellites. And when we were designing the rockets, we were trying to work out what classes of satellites our future customers were going to build. And so, we're predicting kind of the masses and what they want to pay, where they'd want to go, that type of thing when we're designing launch vehicles. And then when we're on the satellite side, the first question we asked is, what launch vehicle can we use? And so launch vehicle design and satellite design and where you could put satellites, so their operational orbit is coupled. And no one really seemed to realize this and think, maybe we're, as the launch vehicle company, we were building the wrong systems for satellites. And so I spent some time, now it's nearly a decade ago, thinking like, okay, what if we started with a clean slate and redesigned space logistics? And I asked the question, are launch vehicles and rockets really the best way to put things in space? So with the rocket, you have to carry everything from the ground. So imagine you're going on vacation, but instead of flying on a normal aircraft with lots of passengers, that airplane is filled with everything you need to take with you. So it's filled with your car, because once you get to the final destination, you want to drive around and do some sightseeing. It's also filled with a ton of gas or petrol to fuel the car. You have to carry everything with you. And so that aircraft, rather than being able to carry 200 passengers and having low cost for each passenger, can just carry you and your family. So the cost to get stuff to space is incredibly high. The second thing that this architecture does is means you can't go very far. So if you fly to another country and then you have to have the car and everything with you, you just can't go very far at all because you're limited by how much mass that aircraft can carry. And this is also true for space. So a satellite that's going to a high orbit above Earth, such as geostationary Earth orbit, more than 50% of that satellite mass when it's launched is actually propellant. And it gets worse if you want to go further away from Earth. And so this fact, the fact that we are using single-use rockets, we have to take everything with us from the start, from the ground, means that we haven't done some really incredible missions. It's part of the reason why we haven't gone back to the moon since the early 1970s. It's part of the reason why we haven't been able to send a lot of payloads beyond Earth orbit, other than for very expensive science missions. So with orbital transfer vehicles, we're essentially doing logistics on the ground, but in space, which is hub and spoke model. So an orbital transfer vehicle is launched once and stays in space, just like the International Space Station. Stays in space, so we've already got that asset kind of in our final destination. We can now launch payloads, so satellites, cargo, to a low orbit. We can maximize the capacity of a rocket to reduce costs, or we can use a smaller rocket. Once that payload is in space, in a low orbit, orbital transfer vehicle can rendezvous with it, capture it, take it to its final destination, and deploy it. And so this reduces cost, and it also means that we can just go further and do more in space. And it's also not a new concept. So NASA had been looking at architectures like this since the 1970s. When NASA had a big Mars program on the heels of Apollo, they really wanted to have the space shuttle working together with a space tug, but they canceled the space tug part of that when they canceled the Mars program in 1973. So like, this is the way to go. And finally, now we have investment and a commercial market that can support this type of business. So it needs to happen.
That's amazing. And who are you collaborating with in all of these projects? Obviously, it's not just you and your team alone. Do you work with other agencies or other contractors to help make something like this happen?
Yeah, so we have two of our biggest customers are NASA and the US Space Force. But other than that, like there's a really great industrial base for space here in the US. So our avionics and our power system and parts of our propulsion system are all from vendors. And we're also working with partners that will do the mission operations. So sit on the ground with human operators at a console controlling our spacecraft. So in terms of being able to do ambitious missions like what we're planning to do, we can do it with a really small team and stay at around 20 to 30 people, even launching 2 spacecraft at once.
And what's the next ambitious mission that you guys are working on?
So our first mission that's launching in a year and a half, it's sending up 2 spacecraft. So one of them is our Orbital Transfer Vehicle. So it's a small dishwasher-sized spacecraft. Most of that spacecraft is actually propulsion systems, so tank, propellant, electric propulsion system. We're launching it together with a different spacecraft that we call Gluon. So the Orbital Transfer Vehicle we call Quark. So Quark and Gluon are launching together. So Gluon has been designed to be a shipping container. So it's really a low-cost computer, so avionics module, a power system, and a communication system that we put onto essentially a metal crate. So we can aggregate or collect multiple customers, put them inside the Gluon shipping container, and move them around at once. So these 2 spacecraft are launching together in January 2024. Both checking them out after they get off the launch vehicle to make sure they're operational. Then Quark is going to rendezvous and dock to Gluon. And so this type of operation where one spacecraft is autonomously detecting, navigating to, and then capturing a client satellite has only been done twice before by a commercial company. And mostly this is done by agencies like NASA, rendezvousing with the International Space Station to get crew and cargo there. So it's going to be cover a lot of firsts just with that first part of the mission. Afterwards, it's successfully docked. We're doing an in-space transit, so we're changing the orbit of both spacecraft, dispensing clients into the new orbit, and then doing some further demonstrations. So doing a refueling demonstration where we're pulling propellant from Gluon to Quark. And then we're also seeing if we can do this operation in more and more challenging environments. So it's an ambitious mission with 2 small and mighty spacecraft that's really going to pave the way for our future commercial operations.
That's awesome. Thank you so much for sharing that. I'm going to switch gears a little bit and ask you a little bit about your own personal journey. You've had a lot of experience working in aerospace, but where did that passion first start from for you?
So I have a really funny story that I like to tell. So I was, let's see, probably 16 or 17. I was in high school in rural Australia, so a very small high school. We had a phenomenal physics teacher who would go off curriculum all the time. And this one lesson, he starts reading from the transcript of, I think it was Apollo 9 or Apollo 10. And so this transcript is essentially just the astronauts talking amongst themselves and occasionally mission control interjecting and asking things. And anyway, there was this segment where the astronauts suddenly stop all of their standard checks and communications with ground control, and they gather by the window and they're saying things like, "Oh golly, oh gosh, look, would you look at that? Isn't it beautiful?" And at this point in reading the transcript, my teacher stopped and looks around at the class and is like, "What do you think the astronauts were looking at?" And we're making guesses like, "Oh, maybe they just came around the side of the Earth and they saw sunrise from space." He's like, "No, okay, maybe they were, I think it was Apollo 9, so they were flying around the backside of the moon and they saw the Earth rise above the horizon of the lunar surface." Teacher again was like, "No." So we're still there pondering what on earth this could be. And he keeps reading. Turns out what the astronauts were looking at was a urine dump. So I think you've had astronauts talk on part of this series before, but what they used to do in Apollo, they don't do it on the International Space Station anymore, is they wanted to keep the mass down. So they would jettison waste from the toilet and blast that into space. But if it's urine, it's a liquid at room temperature and pressure. But when it goes into the vacuum of space, it solidifies instantly. So they did the urine dump. It flies out the side of the spacecraft and crystallizes into this gold cluster of particles. As they're watching it, it collides with something, an antenna, side of the spacecraft, and starts like a slow motion explosion, expanding into this great golden chandelier. Anyway, my physics teacher told this story, and I was like, that is amazing. I want to work in an industry where going to the bathroom is that extraordinary. So that's really what started my passion. And I kind of had a zigzag path to get back to that, but man, I just love that story. I had such a phenomenal teacher, and I'm so glad I get to share that experience that he gave me with a lot of people.
That is an amazing story. I have a lot of jokes that I will hold back. But my first question, do you want to go to space at some point? Is that still on the path for you, or are you happy doing what you're doing now?
Yes, but so I actually started my academic career doing physics and mathematics, and I was about to start a PhD in physics when I realized I really don't like doing experiments. I don't like being a scientist. I don't like doing scientific publications. I worked for 2 weeks as a physicist at a research facility in Sydney, and I was like, I cannot do this. What I really enjoyed doing was designing experiments and setting up experiments and tweaking things. But when I had to go through the crank turning of running an experiment and all the diligence of data entry and analysis, I hated that. So I swapped to engineering. So a lot of the astronauts that we have today are scientists. And so I was like, oh, I really wouldn't enjoy the day job as a scientist astronaut. But once we have a new need for engineer astronauts, then I'd be more interested again.
That's a wonderful answer. And I think, as a former teacher myself, I think students often struggle with knowing the difference between scientists and engineers. I don't know if you want to share anything else about your decision to pursue the engineering side as opposed to science. Maybe anything that would help some of our high school students who are listening would be helpful.
Yeah, so I did my undergraduate degree, so a Bachelor of Science in mathematics and physics, because I was good at that. And it actually was a really great stepping stone to get into engineering. So I managed to get accepted into a master's of engineering, even though I really didn't have any engineering in my undergrad degree. But I think the difference is I am not detail oriented at all. I am very much a big picture person. So doing any detailed analysis, trying to find little errors, I wasn't very good at that. And another thing that really drove me to engineering was, I was kind of at the cusp of starting a PhD, and I was really scared. Through my undergraduate degree, I had done okay because I was really good at replicating a process. I could learn how to solve a differential equation, or do this thing with complex numbers, or do this crazy math sequence. But I was just following a memorized process. And with a PhD, I thought, oh man, I have to create something new, something no one's ever done before. And at that point, this is now nearly 15 years ago, I didn't feel like I had the capability to do that. I learned obviously that I did in a different field, but it was, I think engineering was just a much better match for my personality, because I could enjoy going through the process of designing something, like checking all the boxes as I went through. But then that is really what I enjoyed, rather than using whatever I created in some type of experiment. But there's a lot of overlap between physics and engineering. We have people on our team who have undergraduate degrees in physics who are now working as engineers. So you can definitely walk the line between both of them. but I think the one recommendation I would make, no matter what you do, is learn how to build things. It's a good skill even for a physicist.
Oh, that makes me so happy. I have my Lego set back here that I'm going to be working on after this. I love that. So I know I kind of cut you off and I was asking about wanting to become an astronaut, but you mentioned that your career path took a bunch of turns before it delivered you here. Do you want to tell us a little bit about those turns and maybe how that helped to facilitate what you're doing now?
Yeah, so I already mentioned, like, I had was on the cusp of doing a PhD in physics and then changed and did engineering. So that was felt at the time like it was a very big change, because I entered the engineering world having really just my physics background, and I was expected to have a lot more knowledge than I thought I had. But it was really a sink or swim moment, and I managed to survive. But I was also studying in Sydney, and I realized that I really wanted to be in the space industry. And all this is now, in the late 2000s, like, there wasn't really a space industry in Australia back then. In the past few years, of course, there's been developments with the space agency and now a lot of commercial funding in Australia, but back then there's nothing. So I broke my degree rules and decided to go do an exchange semester to Germany. So I found a university that would take me. I actually put my studies in Australia on hold, went and studied in Germany for 6 months, then came back to Australia, and I was like, I got these credits, can you count them towards my degree? And they were a little annoyed that I'd broken the rules, but eventually they granted those credits. And that decision to bend the rules and really ask for forgiveness rather than permission enabled me to get my first position in industry, working as a propulsion engineer at Astrium, that is now Airbus Defence and Space. So I was working on the Ariane 6 launch vehicle that hopefully launches later this year. But I got there by breaking the rules. Like, they didn't want me leaving the country to go get credit from a different university, but I felt it was really necessary to go out and network in a country where I could work in the field that I loved. So that was one big shift. The other big shift was a few years later, so still in Germany, I had a job that I loved on paper. It sounded incredibly cool, but the day-to-day was a little challenging. And on the side, I started a PhD. So I was doing it through a university in Germany, and it was a topic I really loved. Doing a part-time PhD in Germany is apparently completely normal. I realize that people don't do that in the US anymore. But while I was starting that, and like that was going really well, I won a green card to come to the US. And I nearly didn't come to the US. I had an entry visa that was valid for 6 months. And I was like, I like my PhD, my job's okay, I'll stay here. Until I think it was 2 weeks before my entry visa expired. I'd been pushing to have a new project happen with my day job, and had a really big clash with my manager at the time, who thought it was the wrong direction, didn't want me to get funding. I'd won funding, and he then wanted to take it over. And I remember thinking, like, maybe a change of scenery makes sense. So I ended up flying to the US and landing at JFK Airport at 11 p.m. the day my entry visa expired. And I'm like in the customs line sweating, being like, man, if it gets to midnight, are they going to let me in? It was before midnight by the time I got to the front of the queue. But, I got in, and so I was here in the US, and I was like, oh, okay, I guess I'm living here now. And so it was really just on a whim decision that ended up changing my life and career trajectory completely. So, one thing that I'd recommend is, if you have an opportunity, even if you don't know your immediate next step, if it just opens up more possibilities than your current circumstances, I think absolutely take that opportunity.
Vanessa, that's an amazing story. And I think what Mark was talking about earlier, we learned so many things from what it is that you choose to share with us. And that's something that definitely is going to stick with me. And thank you, Lisa, for sharing that too. She's saying a very courageous and brave steps to be able to take.
I was pretty courageous in my 20s. I don't think I could do that now.
It's a different type of move now, right? Starting a new
Yeah.
company is a different type of move. We had a question, a very specific question in the chat. When you were working at Lockheed, did you know a man named Adam Wigdalski? Did you happen to work with an Adam?
I have to look it up. I don't think so. The site where I worked at Lockheed had 5,000 employees.
Oh,
And most of the programs I worked on had 500. So, but occasionally there is that second degree connection through Lockheed.
awesome. Well, thank you for sharing that. We have another question in the chat. What kind of projects are going up on Gluon and Quark?
So, let's talk about clients that we're launching. So we don't know our final orbit yet. They're still deciding what's called the orbit LTAN, or local time of the ascending node. So I don't have a globe, but I'm going to use my teacup. So we're going into a sun-synchronous orbit, and we're not sure exactly if we're going to cross over the equator at 9 a.m. or 10 a.m. or 11 a.m. So we don't know exactly where we're going to go. So if we're mid-morning, which is where we're hoping, this is a really great orbit for Earth-observing satellites in the visible spectrum. If that's the case, we do have the capacity to carry 8 customers, and they'll likely be from academic institutions, because it's the first launch of our system, so you can ride for a very, very heavy discount if you're willing to take on a little more risk just to get your satellite to space. If we go to a slightly different orbit, we'll solicit payloads from different customers who operate their payloads in different spectrums. But that's the customers. And we really want to demonstrate that we can move a customer and dispense them into their target orbit. I see that there was a follow-up question. So we're dispensing the customers exactly where they need to be. So specific altitude, the specific phasing, if we need to do any changes in the local time of ascending node, so we can do that as well. But once we dispense the customers, we will leave them there. So their systems will be designed for something like 3 to 5 years of operation, and at an orbital altitude of 500 kilometers, they'll be able to stay there for that period of time before their orbit decays due to drag. So we won't be retrieving them. This is all about precision placement and getting them there cheaply. So the other part of the mission that is really most important for us is all of our internal demonstration. So showing that we can do rendezvous and docking and refueling and propulsively move around in space, because that's really cornerstone for our business. We're happy that we have that we get to help out clients while doing that demonstration.
Mark, did you want to ask your follow-up about economics?
Yeah, and maybe it's just a connecting the dots sort of question, but presumably, if I can sort of think out loud as I try to articulate the question, it saves money to have the orbital transfer vehicle, because even if Quark needs fuel, right, and you need to refuel it at some point, it's going to be cheaper to move just the fuel than to say move a whole nother vehicle, like your 747 with the car inside analogy, yes. Right? And then it's so much easier, I presume, to get from one orbit to another, right? I don't know, is there more you could say about how it's a cost savings to have, to refuel your tug instead of moving individual satellites around themselves?
Yeah, so you really hit the nail on the head. So for the main cost saving, which is physics-based. So instead of having to launch a propulsion system or an orbital transfer vehicle with the satellite, that's already in space. So you save mass and volume. So that's the main saving, is all about logistics optimization and reuse. The other ways it reduces costs are, first, it reduces satellite build cost. So a lot of our prospective customers have designed and in some cases built their satellites, and a lot of them have onboard propulsion systems. But for example, we have one customer who has designed their satellites and they've already started deploying them in one plane around the Earth. But what they're realizing is like, oh, our propulsion system isn't big enough to put the satellites in a second plane and third plane and fourth plane, because the launch vehicles typically only service very specific planes. So they would have to upgrade their propulsion system and have a more powerful, more bespoke onboard propulsion system. So their total cost for these, not the first plane, but the second plane and third plane, is $25,000 per kilogram. If we do that service for them, their cost comes down to $10,000 to $15,000 per kilogram. So there's like a 50% cost saving. Most of that is so that they don't have to build a propulsion system or upgrade it themselves. Second way this really saves cost is ride sharing. So we suddenly go from having a couple of passengers on board a rocket to having a full bus. So the payload capacity of a rocket like SpaceX's Falcon 9 is 15 to 20,000 kilograms to get to a low Earth orbit. There are very, very few satellites that weigh that much. Like it's, that's NASA class, that's extreme. Like we never fill up the full capacity of a rocket, but orbital transfer vehicles allow us to do that. So we can amortize launch cost over more payloads, which means everyone pays less. So they're the main ways that we save on costs. There are a few other things that we can do for satellite operators that also save money. Our systems are optimized for moving around, whereas for their systems, propulsion is often a last-minute bolt-on addition, so it's suboptimal. And because of that, it takes longer, it takes more propellant, or it just increases the cost and mass in a way that isn't efficient.
Awesome. Thanks for taking the time for that. It's fun to dig down into the physics of it a little bit.
Yeah. Liz has another more complicated question. If you want to unmute yourself and ask your question, Liz, we'd love to have that.
Yeah, sure. Well, thanks for being here. And I just got off a hike, so I just been enjoying this terrain very much. And I love that somebody has a view of it from space, moving about on one of those images. But I have a question for you. So for instance, for companies like ours, we do gene therapy. We want to do gene therapy to affect human bodies in space so that they can stay in space longer and healthier. Has your company considered creating maybe their own clients in which we could ship? So if we want to do something with the International Space Station, it's a very limited capacity, it's very expensive, you have to get in line, you might have to wait for years. But if your company created containers in which you could put into orbit, and they were re-entry containers in which we could actually GPS once they hit the Earth and collect our data, for instance, that would be really fantastic. Are there any companies looking at that? Like, for instance, creating, your own containers that you throw up there, maybe 100 companies have an experiment in one container. We all, parse the cost. And then these re-enter without destroying the materials. And, as a whole batch, we share the cost for this happening. I just think that would be super useful because there is such limited access to space testing at this time.
Yeah, and the cost per hour of astronaut time on the ISS is also crazy. Mm-hmm. So there are two companies doing this that I am aware of. So one is called the Exploration Company. So an old friend of mine, Hélène Ubi, is founded that company. It's based in Germany and France. Then there's one here in the US that's called Vanessa Space. Their main customers there are manufacturing. They want to produce bulk materials in space, so materials that can really only be made in space. But the Exploration Company is really focused on pharmaceutical companies who are looking to do experiments in space using the space environment. So there are a couple of companies looking at this, and they're also prospective customers of ours. So our main business is moving things around in space. So we can definitely do the launch segment if they need to operate in a different orbit because of either gravity conditions or drag conditions or thermal conditions, then we can move them around. But re-entry technology is very specialized. And having an automated laboratory in space is also really specialized. And so that's what these companies, the Exploration Company and Vanessa Space, are doing.
Thank you. That's cool.
So we have a question here. What was the best project that you've ever worked on? Or what part of your life, if you could do it all over again, what would you want to experience again?
Okay. So the best project that I worked on. So I guess a series of projects. So when I was working at the German Aerospace Center, I worked in two different roles there. So one was as a essentially a system engineer or a system architect on conceptual space missions. And so we're designing missions like one of the payloads that's on Hayabusa 2, Mascot. So that payload was actually a briefcase-sized spacecraft that didn't have propulsion. It was designed to be dropped onto an asteroid, and then it would turn a flywheel inside it to bounce around. So it was like a rolling box spacecraft. It was insane. And to do the design of that, we did it in a week. So where I worked, we had something that we called the Concurrent Engineering Center. So we had essentially a central data model and all of the experts in each discipline. So I normally did propulsion or power. I would sit around in a room for a week and we would design the spacecraft. Spacecraft design is normally a really iterative process. It takes months, but like in that environment, in that facility, having everyone in the same room with a single point of truth data model and everything set up and ready to go, we could do it in a week. And that's like such an empowering experience, being able to accomplish something that from your experience takes months in like such a short amount of time. Like it's one of the best feelings ever. And that's also something that we're replicating pretty well at Atomos. So that was the first part of the question. So second part was, if I could go and live part of my life again. You know, such a tricky question. Sometimes I wish I could combine the best parts of myself from various parts of my life. So, you know, with like the knowledge I have now, but with some of the absolute confidence that comes from naivety of my mid-20s, with my fitness from my early 20s. Like, I wish I could combine this super version of myself and redo some of the experiences that I've had. But I think all of my best experiences related to the space industry are associated with rocket launches. Like, it's just phenomenal. Like, so much more than a test campaign or working on a project. It's like the culmination of all of your effort, and it is just awesome to see. Like, it's just incredible to think that humans can do something like put together a large rocket with 1 million components and have it work. So rocket launches is like one experience I'd always like to relive.
Those are great answers. Thank you for sharing that. What has it been like to be an entrepreneur focused on space?
Being an entrepreneur is, it is, let's say, wonderful chaos. Like, it's really great leading a team, being able to like share my knowledge and experience with people like I'm doing on this call, but then 50% of my time is a lot of the drudge work. Like yesterday, I went and mopped the warehouse of our facility, and for 3 hours today, I was updating some Word documents with some design changes. So very tedious stuff. And a lot of the stuff you do as an engineer is like really, as an entrepreneur is really, really hard. So from working out what on earth to do next to just dealing with adversity, so dealing with customers saying no, higher prospects saying no, investors saying no, you know, I'd say it's tough while being a lot of fun. But, you know, you have to suffer a little bit of pain if you want to make an impact on the world. And so I try to deal with it with grace.
That's awesome. And I'm also really just curious to know, what is it like to be a woman as a leader in a space company?
So, so it's interesting. So in terms of like leading our team, we have a really great team. The two other, so my co-founder is also my husband. So we got married after starting the company together. So we have a fun dynamic. And the other executive in the company is also a guy, but we're a really great cohesive leadership team. And I have not had any issues with being a woman in terms of being a leader with our internal team. And I also really love the opportunity to foster our female engineering staff as well with their personal growth. Where it is a challenge is sometimes in outward facing meetings. I think one of the big examples that I have are either working with some of our customers where they don't expect me to be a technical CEO. And so they'll address questions to my co-founder on the technology, and he'll look at me and be like, Vanessa, can you answer that? And also with fundraising. So, I mean, the data shows it, we all know it through anecdotes that female-led companies just get less investment. And this is because all of the investment money is really coming through white men, and they invest in people who they trust, which are people like them. So it's been really difficult for us to fundraise. And often we see companies that are smaller, with less traction, with less technical maturity, getting funding from investors who told us no. And really the only discriminator between the two companies that could elevate them above us has been the fact that their entire leadership team is male. So the way I deal with setbacks like this is think, our company needs me to be successful, but the fact that I'm a woman means that we're operating on hard mode. They're all playing on easy mode. So once we are successful, the victory will just be that much sweeter. And, hopefully it changes in the future if more companies and founders and women like myself are successful, because we can help change the status quo after we've achieved success. It's very difficult to kind of be at the bottom of the totem pole and say, this isn't fair. So we have to get to the top first to help others up after us.
That was a beautiful answer. And I love the idea of playing on hard mode. That's awesome. Thank you for sharing that. Lisa has a question for us in the chat. I think this will be our last one that we're going to end on. But she's wondering, currently there are 4 rockets at Cape Canaveral. Do you foresee any of your payloads collaborating with vertiports?
So in the near term, we're laser focused on our first mission, and that's not part of it. But ultimately, having collaboration in the supply chain and integration and at launch sites, and all the way through from bus manufacturers to launch integrators to launch integration facilities and launch vehicle operators, we all provide value in different ways, and we're all trying to enable cross compatibility. So yes, I see that in the future, but not immediately.
Awesome. Vanessa, thank you so much for taking the time today to speak with us. I'm going to pass it back over to Mark, who's going to close us out. But thank you again so much for being here.
All right. Well, thank you, Leslie.
Yeah, thank you, Leslie. And thank you again, Vanessa. That was just awesome, fun to learn and to hear your experience and to hear those moving stories. And I think you were following along with the chat too, which I'm also impressed with, by the way. A lot of people in the middle of an interview aren't able to also follow along with that, but people were really excited about the stories you shared and your energy. And I think we're appreciating you being here. So thank you so much.
Yeah, well, thank you for the invitation and for the work that you do as well.
Oh, thank you. And thank you, of course, to everybody who joined us and pitched in and asked questions and participated. It's always fantastic to have you here, and fantastic to see so many returning familiar faces. So thank you guys who keep coming back. And I hope you're all getting something. I know you're all getting something out of this too, because I'm getting something out of every week with these guest speakers. It's just fantastic. If there's not anything else, I will go ahead and end the recording. It looks like we've got a couple minutes if anybody wants to stick around to debrief. But thank you, and thank you, Lisa, and everybody who's dropping their thanks in the chat too. This week, you know what I'm going to do is stop recording instead of end meeting.